So, you are an idiot. Nah, just joking. But do you have that inner gut at 3 a.m. morning? Wait, how does the universe actually work? Congrats. You just unlocked the worst rabbit hole known to man, quantum mechanics. See, when you were a kid, the world seemed simple. Drop an apple, it falls. Push a thing, it moves. Cheat on your math test, you fail anyway. That's called classical physics, the grown-up version of common sense. It runs on rules you can actually see and predict, like gravity makes stuff go down, time only moves forward. Your mom will always find out when you break something. But zoom in far enough, down to the tiny particles that make up literally everything, and the universe just stops caring. All the neat little laws of physics, yeah, they explode. Welcome to quantum mechanics, where particles don't exist until you look at them, can be in two places at once, and somehow know what other particles are doing across the galaxy. Basically, the universe has a normal, logical day job, and then a secret, chaotic nightlife you're not supposed to see. And you, my curious little idiot, just walked straight into it. Before we go quantum, let's appreciate how comforting normal physics used to be. Newton, you know, Apple guy, was like, force equals mass times acceleration. Stuff moves in predictable ways. I'm a genius. Please clap. That worked great, until scientists got nosy and started poking around at atoms. Spoiler, atoms are basically tiny balls of chaos. If classical physics is like a clean, organized IKEA catalog, quantum physics is the room of a 14-year-old Fortnite addict. Nothing makes sense, and it smells weird. Okay, so what are we even looking at? Atoms are made of electrons, protons, neutrons. You've heard this before, but electrons? Oh, they're absolute drama queens. We used to think electrons just orbited the nucleus like little planets around a star. Cute. Then quantum mechanics kicked the door down and said, actually, electrons are everywhere, all at once, until you look at them. Then they just pick a spot, randomly, because screw you. This is called superposition. Imagine you left a slice of pizza in the fridge. Classical physics says, it's either there or it's gone. Quantum mechanics says, it's both there and gone, and also possibly on Mars, until you open the fridge. Then it decides, okay, so superposition is weird. But it gets worse. Scientists were like, cool, let's spy on these particles and figure out what they're doing. Big mistake. The moment you observe a quantum particle, it stops acting like a wave of possibilities and chooses one single state. This is the observer effect, aka the universe's way of saying, mind your own damn business. Example, the double slit experiment. Shoot particles through two tiny slits. If you don't look, they act like waves and create a fancy interference pattern. But if you put up cameras to watch, they stop acting like waves and politely go through one slit or the other, like normal, law-abiding particles. Freak! The particles literally know they're being watched, which means your toaster might also know how many times you've cried in front of it. The more fancy name? Wave-particle duality. Particles are waves, and also particles, at the same time, until you check. This is called wave-particle duality. Imagine your cat is both liquid and solid. Now replace your cat with a photon. Congratulations, you now understand light. Light acts like a wave when it wants to, and like a particle when it feels like it. It's basically the gender-fluid influencer of the physics world. Example, shoot a beam of light through a slit. It bends and spreads like a wave. Now detect it, it goes, nah, I'm a particle now. It's like it's trying to mess with you personally. You never know what you'll get. It's physics, but also a gotcha game. Now, meet Heisenberg. Not this guy, different Heisenberg. He came up with the uncertainty principle, which basically says, you can't know a particle's exact position and exact speed at the same time, no matter how smart you think you are. If you know where it is, you have no idea how fast it's moving. If you know how fast it's moving, you have no clue where it is located. It's like trying to track your drunk friend at a party. You either know they're in the kitchen, or that they're sprinting full speed down the street. Never both. As if this wasn't already nonsense, quantum mechanics gives us entanglement. Basically, two particles interact and become linked, forever. Now, if you mess with one, the other instantly feels it no matter how far apart they are. Instantly, as in faster than light. Einstein hated this. He literally called it spooky action at a distance. It's like you and your best friend say the same dumb joke at the same time in different cities. Coincidence? Nah, that's just quantum joke. This feels like a very powerful superpower to connect to your crush. But what if you could just sneak into her bathroom? Welcome to quantum tunneling. The part of physics where particles see a do not enter sign and enter anyway, because they're petty like that. Let's say you're trapped in a room. There's a locked door. You don't have a key. Classical physics says, you stay in the room, deal with it. Quantum physics says, there's a small chance you'll just appear outside the room. Because math. That's quantum tunneling. Particles passing through barriers they don't have the energy to cross. Like burglars with no tools, but they still end up in your fridge. And it's not just theoretical. Without tunneling, the sun wouldn't shine, your electronics wouldn't work, and you wouldn't exist. So, yeah. Next time you phase through an emotional boundary, just say it was quantum tunneling. Here's another thing that makes no sense. Quantum spin. You'd think spin means something spinning, right? Wrong. Welcome to physics. Particles have something called spin. But they're not spinning. They don't even have a shape to spin. It's just a property, like being left-handed, or being extremely online. Electrons can have spin up or spin down, which sounds like moods, but they're actually quantum states. Also, you can't measure both the spin direction and axis at once, because apparently, spin is shy. This fake spin is so real, we use it in MRI machines and quantum computing. So even though we don't know what spin is, we still use it, because that's science. Using mysterious forces you don't understand until someone stops funding you. Okay, so everything we've talked about, superposition, entanglement, all that fancy shit, it only works if the system is isolated. No air, no light, no nosy particles. But the moment a quantum system interacts with its environment, it stops being weird and becomes normal again. This is quantum decoherence. It's like puberty, but for particles. Before decoherence, your particle is a wave, entangled, full of potential. After decoherence, it's boring, measurable, just another cog in the simulation. Why does this happen? Because the universe doesn't allow quantum chaos in public, only in private, like a respectable lunatic. This is also why we can't observe large objects in superposition, like a car. Or your dad's midlife crisis. You thought particles were the smallest thing? Nope. Welcome to quantum field theory. According to this, particles aren't things, they're excitations in fields. Like electrons, little zaps in the electron field, photons, wiggles in the electromagnetic field, your thoughts, probably glitches in the caffeine field. Just think of it like as you play a guitar and it makes sound. Each vibration has a given frequency and given sound. And like this, each vibration in quantum field gives certain particle. Someone says it's string theory, but let's skip that. So instead of saying this is a particle, you should say this is a temporary ripple in an infinite ocean of chaos. It's the same vibe as this isn't a phase, mom, it's a localized excitation. Okay, so we've established. Particles don't behave until you look at them. Observation changes reality. You can never know everything about them. Some are basically psychic soulmates. So, what do we do with this cursed knowledge? Answer: we build lasers, quantum computers, nuclear bombs, and a bunch of tech we barely understand. Because humans are nothing if not curious little gremlins who turn weird science into ways to break reality. And here's the kicker. Even after more than 100 years, we still don't fully understand quantum mechanics. We just know the math works, kind of like your relationship with your Wi-Fi. So yeah, the universe is a glitchy mess. Particles teleport, time bends, and reality basically lies to your face unless you're looking directly at it. Tunnels are optional. Spins aren't spins, and reality is just a collection of misunderstood waves screaming into the quantum void. But the fact we can even begin to describe this chaos is kind of beautiful. Or terrifying. Mostly terrifying. And that's quantum physics. You still don't get it. But neither do scientists. So fuck it. Go touch grass.